Hello, welcome to my quick explanation of how to do the Marshmallow Speed of Light lab. Now, one thing I do want to point out is that because of the special situation we're in, I'm not expecting you to go out and buy marshmallows. If you have marshmallows at home, they are of course ideal, and so you can use them. But even if you've got something like maybe chocolate chips or something like that, something that could melt rather quickly and obviously in a microwave oven is going to be your best bet. That is, though, also where I want to give another caution, and I always give this caution, which is because you are going to be heating things up in the microwave that potentially can melt very quickly, you do want to stay at the microwave the entire time. It's usually within about the first 10 or 15 seconds if you're using marshmallows that you visibly start to see things melting, so it's not like this takes very long or anything like that. But a few other little notes to keep in mind about doing this lab. One thing that you'll see in the lab manual is that I suggest, if possible and if it is safe, that you take your microwave and look at the back panel of it, because usually on the back panel of the microwave you'll see a measurement that's given for the frequency of the microwaves that it's producing. Now be careful, because you will see something probably that says something like that, 120 VAC 60 Hertz. That's not the frequency we want, because that's talking about 120 volts AC current running at 60 Hertz. That's the electricity going in. So instead we're looking for a number that's probably going to be something like 2.4 gigahertz. That's the frequency of the output microwave radiation. If your microwave doesn't have one of those stickers, or if it's not safe or easy for you to turn around your microwave to look on the back of it, just assume 2.4 gigahertz and your calculations are going to be just fine. Okay, that'll be your assumed frequency. Now, once you've got that frequency, what you want to do is, again, carefully take out the glass turntable that's inside your microwave, because we don't want anything spinning while you're doing this. We're actually depending on the property that microwaves tend to be very directional, and if you're not spinning food inside a microwave, it wouldn't heat evenly. So what you'll need to do is take a coffee mug. At least I suggest a coffee mug because they're ceramic, they're safe to go in the microwave on their own anyways, and you put it upside down in the microwave so that the opening is down here, because you know there's that knobby thing in the center of your microwave that actually does the spinning. We want to cover it with this so that you're covering the spinny thing. That way nothing's going to actually turn. Then take your plate and put it on top of that, okay? And again, balancing it out nice so that it doesn't, fall or anything like that. And then it's all over the plate that you put your marshmallows or chocolate chips or whatever it is that you think will melt in the microwave within a short period of time. Put it in, turn the microwave on high, and start it up. And as soon as you start seeing things melt, and if it's marshmallows that you're using, you'll see very distinct spots where they start to like poof up. Open up the microwave, and if you've got toothpicks, you can poke toothpicks into those spots, or if you've got like a big fat marker like this, you can put little dots. But you want to mark off the locations where the marshmallows, or whatever it was, seem to be melting. And what you'll probably see is that it does follow a little bit of a zigzag pattern. That's actually very, very normal when you're doing this. Then take the plate out carefully again, because it might be kind of hot, and you want to measure how big these distances are between the hot spots. Now effectively what we are doing is treating those as lambda, the wavelength. But this is where things do get a little bit weird, because depending on your microwave, some microwaves send out their microwaves like this, and they're really kind of boring. Some microwaves actually send them out as a standing wave pattern. And what's going to happen is either these distances will be wavelengths, because it would be from the bottom of one wave to the bottom of the next wave, Or if it's setting up a standing wave, then what you're going to have is these hot spots hitting at every half wavelength. Now, what that really means is you've actually got to try starting to do the analysis and doing the calculations of your speed of light, because if you get a number, and I'm not going to say too much here because I want you to play around with the numbers a little bit, but a number that is decidedly different from the actual accepted speed of light, there is something you're going to have to do with your wavelength measurements to correct for this, okay? And I leave that up to you to kind of double check and think about a little bit. It totally depends though on the manufacturer of your microwave oven. So you'll have to kind of play around with that a little bit yourself. But check those numbers out, doing just like a quick little kind of scratch calculation, and you'll know really quickly about whether or not you're reasonably within the range of the speed of light. And most people that do this lab actually find that they get results that are probably at most about 10% error. It actually works really, really well. And also has the benefit that as long as you don't eat ones that you marked up with a marker or something like that, go ahead and eat the marshmallows afterwards. Yay, happiness and joy. But definitely, if you have some questions about this, let me know and I'll try to help you out. Good luck with that lab.